Hello and good evening to all of you. So, guys, once again, a session where there will be huge amount of learning which you are going to go through of a complete course which I have created on architecting and developing a microservices based application. Primarily in this particular session today, I'm going to talk about the first part of the microservices architecture. So first we have to understand why microservices, why one should learn microservices. All this material which I'm sharing with you probably will be shared by my team on demand with you people, right? Introducing brief about myself. My name is Sandeep Soni. Got more than 25 plus years of experience now as I'm talking to you. Started way back in the year 1997, 15th January, I still remember my IT career, and did lot of training, especially lot of architecture on projects involving, though I started with VC++, Visual C++ way back in 97, I moved on to Visual Basic, did ASP, the classic ASP, did SQL Server, did .NET since 2001. In between also moved on to working with SharePoint and a lot of things which I did. Currently working on mostly Azure related products, and very recently I also got into building applications using Microsoft Power Platform, basically no code, low code. How Microsoft has given challenge to the industry. The competitors who also provide no code, low code solutions, especially people like Salesforce and stuff, in terms of Microsoft Power Platform, including Power Apps, Power Automate, Power Agent, and Power BI. That's the point. That's the product I'm working on right now. So very soon probably you can look at some webinars from my side in that particular context also. And for that reason, I would strongly advise you to subscribe to the channel, and also if possible join the WhatsApp groups of Deckensoft so that you can get a regular notification of the events which we keep conducting. What do you get in this course? Yes, you are going to get a very high level introduction to what exactly is microservices in today's and tomorrow's session, and same thing for rest of the period. We are going to do deep dive. Practically we are going to look at all the aspects of microservices. So if you look at the course objective, we will understand first what is architecture and the benefits of microservice over the monolithic architecture. What is precisely the microservice architecture definition? Most important, covering SOA, service oriented architecture, with microservices based architecture. That's something which everybody should really know, because a lot of confusion people find in SOA, service orientation, and microservices. We are going to look at how data is handled in microservices. How do we do communication between microservices? Of course, all these things today at least we are only going to look at a very high level. So if I want to share with you the complete course offered by Deckensoft in architecting and building microservices based application using .NET Core, the first part is all theory. We understand monolithic, microservices architecture, SOA, handling data. Then we get into the practical aspects. We see how to set up from ground up, how to set up a microservices based application, how to perform the CRUD operations, how basically we can use a repository pattern so that we can achieve great amount of reusability with the help of course, entity framework and the business layers, repository, and everything we are going to see in practice. The beauty of this particular course is I start a project in the first session itself and I carry that project step by step. We improve on that particular project on a daily basis. We learn the concept, we immediately apply the concept to the e-store application. So though we are going to start with something very simple, something like a catalog service, a product catalog service for an e-commerce based application, we will see here how the layered architecture applications are built and how a repository pattern is implemented. What is the role of Swagger, which is implemented through Swashbuckle? How do we put some default data? Let's say we would have our first microservice ready at this point of time. But how do we do testing of this microservice? We can definitely test this microservice using Swagger. But to use the microservice, I'm going to also build a proper client application, which can be an ASP.NET MVC project, which I'm going to use for the demos. But if somebody wants, they can also build an Angular application. Because my primary focus is not on the UI, not on the presentation, I am not using Angular. But otherwise, alternatively, in today's modern generation, it's the Angular application which can be built. It's a React application which can be built for accessing the microservices which are delivered as APIs on the server. So here we see what exactly is the backend for front-end concept. We build a proper UI for a product catalog which is used as a microservice. We are not going to add references. Somebody has rightly said in the session itself, microservices basically are going to provide isolation. We'll discuss more on that. We are going to build a solution, and microservices solutions are going to be deployed most of the time in some orchestration system, which can be something like Kubernetes. And a prerequisite for an application to be deployed in Kubernetes is containerize the complete application through Docker. So here the same application what we have built, let it be the catalog service or let it be the UI service, we are going to package them as Docker images. So we will see how Docker file is provided to those Docker application. We will use even SQL Server for that matter through a container. So by now we already have 3 containers in the application, one for the SQL Server database, one would be for the product catalog API, the microservice, and third would be the UI application. How the integration happens in all the 3, especially through Docker. That's what we are going to see in this particular chapter. How one can write a YAML file which can very quickly deploy an application with single line command. Docker compose. That's what we will see in this particular session. Moving forward, we are going to understand how a shopping cart can be built in a microservices based application, wherein we introduce a shopping cart service, which in turn in background is going to make use of Redis cache, a caching service, a distributed caching service, which we are going to host it in Microsoft Azure. But for the development, we would again use a container in our application, which eventually probably in real time would be a Redis cache service in Microsoft Azure infrastructure. So now 2 more containers get added here. One would be your shopping cart service, one will be your Redis cache container. So 3 plus 2, 5 containers we already have in our application at this point of time. Making microservices and not making them secure would be a blunder. So to make microservices secure, we use some authentication and authorization process which we want it to be compatible with multiple environments. OAuth 2 OpenID Connect. We are definitely going to learn deep dive into these 2 things. Understand what is OAuth 2, what is OpenID Connect, what are basically the scopes, what are grants, right? How the JWT token comes into the place. how different types of authentications are performed. Of course, the difference between OAuth 2 and OpenID Connect, first we will do a deep dive in that, and then we will move on to implementing microservices using Azure AD. We want to implement it using Azure AD. How? Yeah, there is a provision where we can also implement using a third-party Identity Server 4, an open source platform actually. We can use either Identity Server 4, which is an open source platform for .NET, or alternatively we use Azure AD. Real time people use Azure AD, and I'm going to use that for implementation of security between the client applications and the services, and of course sharing of service with other services. So service to service communication, UI to service communication, all those things, how roles are going to play an important thing, how scopes will play an important part in the security, all that we will see in this particular chapter. Very important. API gateway implementation, we can use Ocelot, but better option would be making use of something like Microsoft Azure Application Gateway. Ocelot can be used, or in Azure we have got Application Gateway which can be used, and we will see how these gateways will give you the benefit of single point for multiple microservices. Today also we will understand the benefit of that. Microservices have to talk to each other. So what are the different ways the microservices are going to communicate with each other? The comparison between the synchronous communication and asynchronous communication, and implementation of the same using something like an Azure Service Bus, or basically a Service Bus queue or a Service Bus topic. How are we going to do that? That will be the focus on this particular module. Implementing CQRS pattern, segregation of the querying and the CRUD operations, basically update delete operations. We call it as domain model versus read-in model, separation. How to implement that in our microservices based application? Again, we look at practically. The most important part would be, how is domain driven pattern so important when we create microservices based architecture? What is the role of domain driven pattern? How should one think when they are working on a microservices based application so that they can segregate different services functionalities in different, they can segregate different domain functionalities in different services. How the services are going to communicate with each other. What is command and command handler pattern? Those things we are going to look at in this particular chapter. We will see how to handle failures. Not possible that microservices would never return error. Very good chance that the microservices are going to return some error. So if microservices are going into deadlock state, what is the role of circuit breaker pattern? How poly can be used for doing multiple attempts? So these kind of things we are going to look at in handling failures, and eventually we will deploy microservices. The whole application which we have developed, we see two ways of deploying it. One is in a non-containerized environment, something like Azure App Service, or it can also be deployed into a Kubernetes server, something like AKS. How a complete application can be deployed in a Kubernetes platform, which can be on-premise Kubernetes platform, which can be AKS, which can be EKS. It can be any of your Kubernetes orchestration system in which you will have to write the YAML files and deploy the microservices. So the most beautiful aspect of this particular course, guys, is the course takes you not only through the theory session. Theory session I've made it public. Today, tomorrow, the theory sessions are going to finish almost. Everything which I have shown to you, I am going to go deep dive to an extent, of course, in context of concepts in today's session and tomorrow's session. I'm going to explain to you all these aspects. all this which is made up of syllabus. But the critical aspect of it is looking at them in practical, and trust me, I have not seen even a single course on internet which can match this particular approach. After a huge amount of survey, I saw that there is a big vacuum in a single course which can not only talk microservices architecture in theory, but also demonstrate the same things in practical. Yes, one of the most complicated course which I have created, and huge amount of time invested on this. If you are part of this course, definitely what you are only going to get is the chewed food ready to swallow. You already have things. You will get the handouts, complete detailed handouts you are going to get, where you can practice each and every topic. In microservices course, you will get all the handouts of every topic. All these handouts I am going to share with you people. You can pick up any one particular topic and you will find steps. Do this first, copy this code, do this next, copy this code, do this, do this, do this, do this. Everything if you do in a very systematic manner, you are already building the blocks. And with these blocks, you will create a building. So it's not that we first build the blocks and then make a building. We are building a block, that block immediately we are putting in the building. And gradually the whole building comes up. That's what is the approach you will see in this particular training, the complete course if you are looking at. So yes, I definitely invite all of you to join this course if it is feasible to you in terms of time, money and various aspects. All the details you will find over here. This particular course is going to also give you access to the recorded session. I'm going to record each and every class and they will be made available to you over here. Over here you'll have the complete course available. Yes, just because this course is expensive, I know definitely it is expensive. We do have one package created. You can go to the Microsoft Azure suite. In that there is a package created which comprises of Docker, Kubernetes and microservices architecture all together at a nominal fee. So it's your call if you want to take it. I can definitely promise you only one thing. Every penny invested, every second invested, money, time, both will be worth and would be helpful to reap you huge amount of benefits. All said, so I'm sure I would love to see some of your feedback on how the whole course has been compiled. What is your opinion about how this course has been compiled? Maybe I would love to see your inputs in the chat. I'll get 2 minutes break in the meantime, and I am ready to go after this with a detailed session on the topic. I'll just wait 2 minutes and then I'm going to speak for at least 1.5 hours to 2 hours on the topic today, and of course the second part you'll see from tomorrow. So let me know what is your opinion about how the course has been compiled. I definitely want to take your feedback on this context. Would something adding help the course, or is it already good? If it is good, appreciate. If it is bad, give me the feedback. Straightforward. How to set up the environment? Yes, we are going to cover in detail. No complete information about microservices on internet. That statement is true only till you do not reach our website. I'm telling you, this is a definitely complete course. So I believe with all these said, you're ready. You're ready to fly. Wow, love to learn. Are we going to deploy to AWS? No, I'm not a fan of AWS. I'm definitely a fan of Microsoft and Microsoft Azure products. So please excuse me. My knowledge on AWS is very minimal. Something which probably never motivated me to leave the Microsoft arena. So I could not. I tried AWS, but I could not do it because the Microsoft keeps me so busy that I hardly get time to look into other aspects. So AWS, I'm not going to do a lot. Maybe whatever I teach you here in this particular course through Azure, you have to map it to Microsoft, to AWS. You have to do that. So that's what we are going to majorly work with Azure, not with Microsoft. Are we going to learn Saga pattern? No, not to that extent. We may not want to touch products. It's a generalized course which helps you to create microservices from the built-in solutions which are provided as part of .NET Core. So otherwise there is an innumerable number of things which we have to touch, may not be feasible in this particular kind of course. Azure is enough. How deeply Docker and container topics would be covered along with microservices course? Microservices course doesn't teach microservices course doesn't teach you Docker, doesn't teach you microservices. Those topics are already covered in my batch till last week, and the latest updated videos are there on the site. So if you are looking at deep dive into microservices, and before that or together with it, if you want to have very good knowledge of these two, yes, one of the best content you can find over here. For Docker, in deep, we have covered everything, and of course for Kubernetes, everything is covered. All the aspects are covered. The same microservices project, how it is deployed in a Kubernetes cluster is here. Of course, this part I'm going to teach in this particular batch also. So you have to take that as an extra package. If you're not interested in Docker and Kubernetes, that's your choice. But I would suggest you take it as a package so that you get the complete bundle. So right. Will I be going through each and every line of code and explain? Mostly yes. I'm going to take the code from the handout, and in front of you I'm going to add the code to the project. So as I'm adding the code to the project, I'll tell you where you are supposed to add the code to the project and why you are adding that code. That is more important. I may not be able to write the code in front of you because that would take huge amount of time. So the whole handout has predefined code, but plug and play. You have to take it from here, put it in the right place. That's how the whole model is going to be. Yes, prior knowledge of ASP.NET Core is very beneficial. Now, I'll take the rest of the questions later, but let's begin. Let's start with what exactly is a monolithic architecture. First, if we can understand what is a monolithic architecture, we should definitely be able to understand the benefits of microservices, because the road to microservices goes via monolithic architecture. So people in the industry has been developing applications for quite some time now. More than 2-3 decades, large scale applications have been developed. Let's say web-based applications have been quite popular, maybe from late 90s of the previous century to even today for that matter. People want to host their applications on internet specifically. So they have moved from desktop to internet-based web servers, and on these web servers the applications would be deployed, and these applications would be consumed from a browser. Almost every application has followed a single tier software application pattern. Everybody, no doubt, has used multi-layer architecture, but they have used single tier architecture, multi-layered single tier architecture. Now, what is this multi-layered single tier architecture? When I say multi-layered, the application was divided into user interface, business layer, and database interface, or data interface you call it, data access layer you call it, DAL layer you call it. The presentation and the user interface layer was solely responsible for providing or producing some kind of user output which can be viewed in the browser. HTML, JavaScript, CSS, and in a lot of cases, JSON or XML output would be produced. That's what is the purpose of UI layer. Then we have got the business logic layer. That's where the business rules are implemented. How probably the product price has to be calculated based on various other factors can be a business logic rule. If a user has applied for a discount, this is the cost. But if he has already availed a discount on 2 products, and if he is willing to buy 5 products, the cost of the product would be totally different. So these kind of logics are implemented in business logic layer. Or you can take a simple example, how should the salary of an employee be computed on a monthly basis based on the number of leaves which he has taken, based on the paid leaves, medical leaves, non-paid. I mean, so many factors which will drive the salary computation. That can be a business logic. Then definitely the data is ultimately going to be stored in database, and that part we will take care of through the data access layer, which is solely responsible for executing queries, which can be select query, insert query, update query, edit query, solely responsible for execution of queries and fetching the data. So developers always distributed their task in multiple layers. Ultimately, if you look at it, they are nothing but classes. As a developer, you write a class. You write a class where the presentation is constructed. You write a class where the business is computed. You write a class where the data access is made. But all these classes, you would most of the time run in a single process. On a web server, we will deploy our application, and the whole application is going to be loaded as a single process in memory. Maybe somebody has built the business logic layer in a class library. A separate class library can be used for the data access layer. But these class libraries are all ultimately loaded in the same process where my web application is hosted on the web server. And that's why we call it as a single tier software application. A software application where the user interface, the data access code, and all aspects are loaded into a single program or single process on a single platform. So yes, a monolithic application is a self-contained, everything it needs is there and independent from other computing applications. There can be many other applications which are deployed on the same web server. Probably each website itself is treated as one web application, or in a single website we might have multiple web applications pertaining to the different categories of that particular organization. But every self-contained application was independent from another application. So this is how people have been building monolithic applications all the time, maybe using .NET, maybe using Java, maybe using Python, maybe using PHP, or you might use Ruby on Rails. It's your choice what language you want to use, what technology you want to use, but you develop your complete application as a single process in which everything is developed as classes, and these classes are integrated through their respective objects. So when we wanted to deploy the monolithic application, what are the various options? See, development is one part, but the story doesn't end with development. We also want ease of deployment. So all these web applications which were developed, one would publish it, package it, and deploy it on a on-premise server. That means within your organization, you might use one dedicated physical server, and on that server, you would put all your application components and make it available to people, maybe limited to your organization, or sometimes maybe to people on internet if it is a public application. You also have options of nowadays deploying in cloud, whether it is Azure, AWS, GCP, Alibaba, IBM. Oh, so many cloud options are available. Wherever you want, you can deploy your applications in cloud. In such kind of cases, you might choose to use something like virtual machines. Most of the time, when we have legacy applications which have been developed quite long back, and we don't want to touch the source code and disturb them. We want them to work as it is, but we want to migrate them from on-premise to cloud. Then we preferably use virtual machines. But one virtual machine may not be sufficient in most of the circumstances because of the kind of load the applications would probably receive. In that kind of case, we use the concept of VM scale sets, where we have a collection of virtual machines being created, and most important is they can scale up and they can scale down. Basically not scale up, scale down. They can scale out horizontally and they can scale in with ease. I want 5 instances of my virtual machine. I should be able to change a number and automatically everything is taken care of. But here also ultimately in background, a virtual machine is only used. Scale set is a service which in turn is going to use virtual machine, and definitely also all these virtual machines will be exposed via a load balancer. Legacy applications, this is the best option. Without disturbing, if you want to migrate your applications from on-premise to cloud, this is the best option. Modern applications which do not have to be integrated deeply with the operating system, which do not need any kind of configurations to be done at operating system level manually. Of course, .NET Framework applications, .NET Core applications, Java 8, Java 11 applications, latest PHP, Python, Ruby applications, modern applications which do not need us to tweak something at the machine level or at the operating system level. For them, we can use PaaS, Platform as a Service option, which is Azure App Service. Definitely, this is the most preferred option for monolithic application, because with least amount of effort, we can deploy our applications in cloud using Azure App Service. Of course, something similar is provided by AWS and GCP too. Alternatively, you can bundle your application, complete .NET monolithic application, Java monolithic application, Python monolithic application, everything you bundle into a single Docker image and push that particular image to the Docker registry. You can definitely do that. And once you have image in the Docker registry, from there you can load it and run as a app service container. You can run a container on a virtual machine, or you can use something like a Azure Container Instance as Service. Multiple options become open when we want to deploy the application through a Docker image. And that's the most favorable and favorite option of people because of the comfort they would have in deployment, as the package is going to comprise of everything required for application execution. So these are the various options which people have been using for deploying monolithic applications. So what are the benefits because of this? We look at, see, we use the language of our choice, the favorite language of our choice for development. We use one of the option for deployment. So what is the benefit? It becomes simple to develop. it becomes simple to test, it becomes simple to deploy, and it becomes simple to scale. When we have used something like ScaleSet or an app service, it's all about just changing a number at one place and it can scale horizontally. For that matter, even scaling vertically is absolutely not at all difficult. Just about changing the size of the virtual machine or the SKU of the app service plan in app service is quite easily possible, and that too without shutting down your machines. Easy to test, everything is at one place. Doing testing like unit testing, integration testing is quite easy, and if you want to do UI testing, we have an excellent product, something like Selenium. So testing of application was quite easy with the help of Selenium, UI testing, or various other tools which are available in the market. Easy to deploy. Why? It hardly takes few clicks when we want to deploy into app service, or even if you have used Docker images, it's all about properly writing the Docker file and that does the job. Good. All these are the reasons why microservices were not so popular till date. People are very comfortable building monolithic architecture application because of all these reasons. But I am now exposing to you the reasons why microservices have evolved, the limitations, the drawbacks of the monolithic architecture. See, unlike in the past, today projects start and they never end. If a product becomes a success on internet, it becomes a bigger organization and the product only goes deeper and deeper into development. And as we go deeper into the development with time, the code is going to get large. The code base will become huge. So many classes are getting added at one place, and you will find that it's too complex to understand all the existing code. It will become like your storeroom in which you will put everything which is extra in your house and probably not even look at it for a long time. And today if you want to search for something which is important, you'll have to search each and everything in the storeroom, garbage room. That kind of thing is happening for extremely large scale monolithic application with time. It makes it difficult to fully understand and make changes to the code fast and correctly, because so much connection is there between each other there. I make change at one place and that might end up breaking the whole system. One class I change the logic, but the logic has been used in so many other places that I would not probably remember where all I have to probably test it, and the system might break. Definitely, with so many modules all being loaded in single process, the startup time is going to be pretty high. You launch the application and so many modules have to code, so many modules have to load, and each and every module which has to load will execute some startup code, some initialization code, and that overall would contribute to a huge amount of startup, which will give a very bad experience to the user. The startup is going to be slow. If any updates are to be done to any part of the application, what will I have to do? One small part, maybe the title of the page has to be changed. But just because I wanted to change the title, the complete system has to be redeployed as it is running in one single process. Yes, huge amount of manual testing has to be performed because the system has become so complicated, interlinked with each other in different parts. It's going to be extensive manual testing requirement. What I said is simple to scale. Now I'm changing the sentence. I'm saying difficult to scale. Why? No project is going to be around one single module. Every project is going to work with multiple modules. If you look at a typical e-commerce based application, in this typical e-commerce based application, you will find a catalog module, a shopping cart module, you'll find a payment gateway module, you'll find the order module, you'll find a notification module. So there are multiple modules in every project which we develop. And what is that product catalog has to do with probably a placement, order placement or order execution. They are independent. But because it is monolithic, they're all at one place. So if the load is increasing, the whole set has to be replicated. The fact is, product catalog is viewed a lot more number of times by us than the actual placement of order or even adding of items into the cart. Cart management pages are used much less when compared to the product catalog pages, and cart and order management pages are used much less when compared to the cart management pages, and so is the gateway pages requirement. But what is happening in monolithic? Whole system is replicated on every system, every instance. We may not need order management 10 instances, but because catalog requirement is 10 instances, order management replicates 10 times. That's why we say it is difficult to scale when different modules have conflicting resource requirement. The biggest problem, one terrorist at home will spoil the complete family. One component of the application has a memory leakage, can crash the complete application, will bring down the entire process because it will cascade. Everything is in one single process. So leakage in one place will simply turn into a insufficient memory exception and crash the entire process. When the entire process crashes, a new process has to be created. A new process will again have huge amount of startup time. Extremely bad experience for the user. The impact of bug in one will cascade to the other. Everything is interlinked. Monolithic applications have a barrier of adopting new technology. Once upon a time, that technology was the most popular and most favorable. I had resources available in that technology with ease and I started using it. But today, for a new requirement, we have better options available. Let's say for that matter, I may have catalog management implementation, maybe in Java or .NET Core, much easier. So imagine I've used Java for development of my application. I wanted to add now the AI features, and somehow I realized Python is better for implementing AI and ML than using Java. Or maybe the language R is better for implementing AI and ML. So can I switch my existing complete application to R language or Python language? No. Or doing the new features which are much easier in Python and R would become very difficult if I want to do in Java because the appropriate APIs and libraries are not available in Java. But can we have multiple languages code in one single process? Impossible. If an application is hosting .NET application, .NET runtime has to be loaded and everything should be in .NET. If your application is Java application, Java runtime has to be loaded and everything should be in Java. You cannot do mix and match of things within the same process. So we are now having a barrier of adopting new technology, though we know those options are available. We are stuck with what we decided in the beginning. And that can become expensive for both cost and time. And monolithic pattern itself is against the very basic principle of containerization, where one container is supposed to do one thing and it should do only that thing and nothing else. But here what is happening? When we create a single Docker image, and from that Docker image if I create a container, single container is performing multiple jobs. the very definition of containerization is violated when we package it as a single Docker image. Because you are then going to do everything in one process, and containerization is definitely not for that purpose. So knowing all these problems of the monolithic architecture, I now introduce to you what are microservices. What is a microservices based architecture? Let's look at it, this particular subject now. Microservices, micro, very small, not even mini, we are saying micro, much smaller than mini. And services, very small services. So idea is simple. You have a large application which is monolithic. Now you break it into multiple independent containers. Each container having its own functionality implemented, also having the ability to integrate with other containers so that there can be communication between them. So basically it's all about an architectural style. Microservices is an architecture actually. As per this architecture, a large application is broken into small services, very small services, where each service is going to be developed independently, versioned independently, scaled independently, deployed independently, maintained independently, but still be able to communicate with other services in a well-defined standard protocol form. So large application, we are breaking into small pieces, and by breaking them into small pieces, we are making the job easy to develop. But breaking them into small pieces will make it easy, but what is also important is we should be able to gather them back. Basically, it's all about moving from one process to multiple process, moving from centralized application development to distributed application development. We are no more working with single platform for development. We are working now with multiple servers, multiple platforms, maybe multiple technologies also if needed, because we have chopped things into pieces. So it's all about each microservice being developed by itself as a small application that has its own hexagonal architecture. Every microservice will have now a user interface layer if needed. Every microservice will have a business logic. Every microservice will have the data access. But they are developed independently. The hexagon is independent for each and every microservice. Every microservice will have this now. Product catalog service will have its own UI, business, data access. The shopping cart service will have its own UI, business and data access. Every service will have its own hexagon. The idea is simple: to split the application into a set of smaller interconnected services. So this is one service which will perform an action. This is another service which will perform an action. Each and every box is one service which may or may not run in the same machine, but definitely each one of them run in a different process. Every service is going to have its own database. See the independency. I'm saying they are independently developed. So I may choose in one service SQL Server. I would say the other service, okay, Cosmos DB, NoSQL is a better option. So let me choose Cosmos DB over here. Somebody else says, no, Cosmos DB or SQL Server is not better. For this, I would use MySQL. They would have the option. Every service will have an option of choosing its own database. And thus, isolating itself from the other service. But as shown in the diagram, you can see certain microservices further dependent on other microservices. There can be a UI which will invoke the functionality of a microservice, which in turn would probably invoke the service on another machine or maybe same machine, and that in turn again will talk to the database and return the result back to the client. Rather, even the UI will be deployed as one of the microservices. So microservices architecture is all about, in one box only a lot of functionality was there, all that is broken and distributed into different services. A monolithic architecture e-commerce application would be, in a single process we would have storefront UI, we might have account services, cart services, shopping services, data access service. All these are running in one single process, and we repeat multiple processes on different machines, wherein each process is going to take its own load. The other process on another machine will take its own load, and the load is distributed through load balancer. And all these processes on different machines would connect to the same database. Microservices, the story has changed. The same application is now going to be architected differently. We'll have accounting service as one microservice running in one process, having its load balancer. Cart service running in one process or multiple process having its own load balance. Every service is running independently, developed independently, deployed independently, versioned independently, maintained independently, including the front-end services are deployed independently. So what are the benefits? Why should we move on to microservices architecture? How come microservices architecture can solve all the problems which we have seen earlier in a monolithic architecture? Let's see that part. And for this you have to understand what are the different characteristics, and because of those characteristics, what are the benefits of the microservices architecture. This is the characteristics of a microservices architecture application. They have to do this, and because that character is there, this is the outcome, this is the benefit. Let's see one by one. I already said microservices are relatively small, very small. Microservices are relatively small and implement a specific end-to-end domain. Catalog management they have taken, all aspects of catalog management we will implement in that microservice. All aspects of catalog management, maybe search by product name, filter by price, rating, everything what we want to provide to the user for viewing the catalog, the products and the details about the product, we would implement that whole thing in a single microservice. End-to-end domain, or you call it as business functionality, both are same, in a certain context boundary. The term context boundary is catalog management, that's the context. In context of catalog management, all aspects, all functionalities will be part of one single microservice. Because of this, the advantage is what? I become domain specialist. It becomes easy for me to be a developer to understand that particular domain where I need to focus on day-to-day basis for building the functionality through technology. I am only worried about the catalog management and the related terms. Damn it, I don't have to worry about how the banking is going to work because the payment gateway has to. I'm not interested. There is another team, another set of people who are working on that particular microservice for payment gateway integration. It is quicker to evolve and release business features because I become domain specialist. They are smaller and easier to analyze. We are working focused on one particular aspect of business. Quite obviously, it's going to be easy for me to evolve that, and definitely testability is going to improve and fault isolation will also happen. I know problem is in catalog management. Why the hell I should look at order management? Why should I worry about what is happening in the payment gateway? I'm only focused on the aspect in which I am doing the development, And if there is a problem, I know this is the area I have to look at. So making microservices small gives you all these benefits, and this is the character. You cannot build a large microservice with thousands of lines of code. You can't. You should not. If you do that, you again tend to become a simple monolithic or maybe service-oriented application, but not microservices. Micro. That aspect of the business only it should deal with, not with other aspects of the business. And definitely because the smaller the services are, you only need small engineering teams. You don't need 100 people working on same project now. One service, maybe 2 people, maybe 3 people, worst case 5 people, one service, they would only focus on building that service. Another service, another set of people. So it may happen that the engineering team will become smaller, which is pertaining to that particular microservice, and that's how it is supposed to be. Each service can be developed independently by a team that is focused on that service. And beautiful thing is, each team will have the option of choosing their language. I may prefer doing in .NET because I feel comfortable with it. My another team who is building a different service in the same project would prefer using Java. Somebody else might do it in Python. But how will this all integrate? They talk to each other through standard communication. They don't talk to each other by making direct calls. They would use standard protocol, something like HTTP protocol would be used for communication. And I would bundle each microservice along with all its dependencies in one Docker container. So deploying Java application for a .NET client is absolutely no difficult because I'm not interested. What is Java? What is .NET? I'm interested in the public functionality provided by that service to consume it. Basically, you don't need to have a long-term commitment to the same technology stack. As with time, if the technology is getting improved, we would like to improve our microservices with that technology. New functionality can be built on new technology, and existing application can be extended. Every microservice is going to be deployed independently. It's not about building them independently, but also deployed independently. I am building a product catalog service. I will package it as one container, and other team is doing the order management service. They are going to package it as a separate container. So I make changes to my service. I would only deploy that container. I don't want to work or disturb with the order management. I want to give new functionality. I upgrade my service independently. By even deploying them independently, the downtime is going to be reduced or almost no downtime. If order management has to be changed, why should the whole site be brought down? Maybe a major change is going to happen in order management database schema, but because the monolithic architecture is there, the whole system will be brought down. But now it is not like that. Let people continue browsing the catalog, but at that moment of time, for a short period of time, maybe they will not be able to place the order. They would be able to view the products, they would be able to add the products to the cart, but they would not be able to they will not be able to place the order because order management is undergoing the change. Only for that there is a downtime. Complete system will not go down. And because independently we are deploying, we can use the DevOps tools, continuous integration, continuous deployment, and deploy them independently. For each microservice, I'm going to have a separate repository. As soon as the code changes happen to that repository, we might trigger automatically one CI pipeline which will generate some artifacts, and that can further trigger a CD pipeline which will take care of deploying that particular microservice, maybe using blue-green deployment pattern, maybe using canary deployment pattern, whatever, ensuring that there is either no downtime or at least amount of downtime. Continuous deployment is possible. Other systems will not be affected when this particular service is being upgraded. Every service can be scaled independently. Catalog service needs more load because that is viewed by people a lot. That container I will run 10 instances. Maybe order management needs less load. I would run 3 instances. Shopping cart is viewed more than order management. I would run 6 instances. Effective utilization of memory and the processor time. Big advantage, we do not have a single point of failure. We are not dependent on a single database or single service. As I already said, if one service fails or the database of that particular service fails, the others would still continue to run without any problem. Each service runs in its own process. This is one of the characteristics. You cannot merge all the services to run in one single process. You have to run them in different processes, and you should still be able to make them communicate with each other. As I said earlier, some standard protocols have to be used. HTTP, HTTPS for secured connection, web sockets for reverse communication, or AMQP for asynchronous communication. We'll discuss more on that. Definitely every service in its characteristics require a unique name, because we are now talking about multiple services. Imagine in one family 10 people are there, and these 10 people have all independent work. So we definitely need to identify them individually by different name. Services needs to be identified like that with unique names, and with that name it should be discoverable. What is the current location of the service in a network? If it is, that's a need in building a microservices based architecture. Compulsory, we should ensure that they are resilient to failure, ensuring high availability. We cannot run a single instance of a service, minimum 2, maybe more. So by any chance, if one fails, we will still have the other available through which we can make the functionality served for different customers. High availability reasons, they should be replicated across multiple instances. Resiliency. So these are all characteristics. They should be relatively small. There should be a small engineering team used for developing them. They should be deployed independently. They should be scaled independently. There should not be a single point of failure. They should communicate with each other using standard protocols. There should be a unique name identifying, and they should be resilient to failure. These are all characteristics of a microservices based architected application. You deviate from one of these, you are deviating from microservices. It's a very easy checklist. Do this, do this, do this, do this, do this, and you have a complete list that proves that your service is microservice or not. Very simple checklist. Design principles. When you are designing a microservices based application, what are the different design principles? Domain centric. As I told you, every service should be focused on one thing, and it should be focused on that thing only. Domain centric. Perform actions only to a specific business domain, and it should be completely focused on that particular domain. Single responsibility principle. SRP we call it. Adhere to SRP, single responsibility principle. Decoupled. Every service should be independent of the other service, to the extent that the communication should be asynchronous communication. I should not be calling one microservice and wait for the response. Decoupled. I'll tell the microservice you do something, and I will continue with my job. And whenever that microservice completes it, it will inform me that it has completed the task. Decoupled communication has to happen. Every microservice should be deployed and scaled independently, autonomous, resilient. I already explained to you. You should have multiple instances, or you should have a retry logic implemented so that abrupt termination should not happen. Centralized monitoring system, and you should use CI/CD pipeline for deployment, automation. So these are all the design principles. You are supposed to keep these design principles in mind when you are creating a microservices based application. The success of microservice is already proved in these large organizations, Uber, Netflix, Amazon, eBay, Sound, all these are case studies by themselves upon how successful are microservices if implemented in a very systematic way. So now that we understand what is a microservice, what are the benefits of the microservice because of the respective characteristics, the big question arises, how are we going to distinguish them from service-oriented architecture? See, in monolithic, we had everything in one process. In service orientation, that one large process we divided into different services. And these services probably we host it on one server, or we would probably host it on different servers. And these things will further now broken into small microservices. That's how the transition happened. Monolithic to SOA to microservices. So it becomes really tough to understand where is actually the separation going to happen between the service-oriented architecture and microservices architecture. Coarse-grained, fine-grained. In service-oriented architecture, definitely it is also a collection of service. But the definition of microservices says they should be developed independently, they should be deployed independently, they should be... That definition doesn't apply to service orientation. They would probably still be developed together, and there can be communication with each other. That too, synchronous communication is more common between them. You call the service, you get the response. And unless you get the response, you don't proceed further. So there is a direct coupling between the calling service and the called service. So this kind of problems exist in service orientation. So something like this. Communication in service orientation passes through an ESB, industry used something called as Enterprise Service Bus. So our UI layer would use this USB, and this USB will provide access to the various services people used in the background. Unfortunately, Enterprise Service Bus gave a facility where we could write logic to integrate multiple services. But because of that facility, what happened? People started writing so much logic in Enterprise Service Bus layer that it became tightly coupled to the service, and services became tightly coupled to each other. UI will call the functionality of ESB, and ESB in background would call the functionality of service. That's how it was supposed to be. But people, rather than writing code in service, ended up unintentionally though writing in Enterprise Service Bus. That means in single layer everything started coming up again. And worst problem was these services all are eventually going to use a common database. So this is the architecture which was used in service orientation with the existence of Enterprise Service Bus. Microservices says, no, get rid of that damn Enterprise Service Bus. What people were writing in ESB to integrate multiple microservices, that itself should be part of the microservices programming, and every microservice should use the corresponding database of its own. But if you are a .NET programmer, Java programmer, Python programmer, remember, these are nothing but APIs. Service-oriented architecture requires you to write a service which will be a RESTful service. Microservices also would be a RESTful service only. The type of project for service and microservice is same. But the way you are thinking while building the application is completely different. No common database concept. Every service should have different database altogether, and there should not be any direct communication, common logic. So when we are talking about the scope, enterprise-wide reusability. Once we have the ESB layer, all the applications would talk to the same ESB layer. Multiple UIs would be there, all talking to the ESB layer, and thus taking the benefit of reusing the enterprise level logic implementation. No, in service orientation, it is always application specific. For this particular application, this particular domain, this particular functionality, this is what should be written in this particular service. Should not be bothered about the other. Application-wide reusability is achieved, not the enterprise-wide reusability. The focus itself has changed. A large corporate might have hundreds of applications. Hundreds of applications would use common ESB layer. No, here every application will have its own reusability extent. That's it. Most of the time, the synchronous communication is going to happen between services. One service, this is actually a service only, would call the functionality of another service and wait for the response, and then call the functionality of another service and wait for the response. And when overall response is accumulated, then the response is returned. One of these not performs well, the overall health of the system would get impacted. In microservices, most of the time the communication is asynchronous. They are not going to talk to each other directly. Basically, they use something called as a publisher and subscriber model for programming. So there will be a queue in which a message is going to be posted and the other will take the message from here. So I will post a message and forget about it, other whenever it wakes up. Basically, if this is a telephone kind of communication, this is an email kind of communication. I don't want you to listen to me when you are in need of a message from me. I'll send you an email. You read the mail whenever you like. Asynchronous communication. Or the difference is live session and a recorded session. Learn at your own pace. Interactive imperative model. Coding is a lot. You wait, you call, wait for the response. You call, wait for the response. Reactive programming. Because something happened, I would do this kind of coding. I would execute this logic. The price in the product catalog service for a given product has changed. But if the product was already added into a shopping cart, the shopping cart should automatically know that the price has changed in this, and it should be able to trigger some code. Reactive programming, event driven, callback driven programming, this is in microservices. Here, call, synchronous. Hundreds and thousands of lines of code you will write here. You're not supposed to write huge amount of code here. Pertaining to that service, whatever is the limited functionality that you do. Stateful. Most of the time they are stateful. These are stateless, very lightweight. They get destroyed and recreated, no problem. Whatever state has to be there, that probably is persisted in the disk or maybe in a centralized storage, which is proportionately, which is selected on the basis of the type of data we are going to deal with. Every microservice can have the choice of using its own data format. Here, RDBMS. I like Oracle initially. I damn stay with Oracle permanently. Today, NoSQL is far better for extraordinary large-scale database. I don't have the option because I have already sticked to Oracle. DevOps people don't find a lot of interest here because ultimately everything has to be deployed as one unit. DevOps will find huge focus. And this is one of the reasons why DevOps have suddenly become so much in demand in the industry. You will see everywhere left and right hiring is happening for the DevOps engineers. Somebody who can deliver. I'm talking about quality DevOps engineer. So this is how you should distinguish at a very high level. Every service in microservice has got its own database. Every service is independently developed version. So is not the cases with service orientation. Service orientation done in a right way. Service orientation done in a right way is what is a microservices architecture. You're still doing services only, no? But you do it in a very systematic way. Separate them, make them independent, run them in independent process. Invoke them using queues, connect them using queues. Use standard protocols for communication, no native communication. In service orientation, very good possibility that native communication protocols can be used. People who understand WCF, Windows Communication Foundation, which was used for building services in the past in Microsoft community. They had native protocols, net binding, basically net TCP binding, all they were native. They were not supported by all the technologies, all the frameworks, all the runtimes other than Microsoft. That kind of thing will not happen in microservices architecture. What is open, what is standard, only that should be used for development of microservices communication with the rest of the world. So this is very, very, very important. You should understand microservices are different than your service orientation. You cannot treat service orientation and microservices architecture as same, though the foundation is on the same template of the project which you are going to use in your language. The template which I am going to use in development in .NET would be Web API, whether it is service orientation, whether it is microservice, the same template is going to be used, but the architecture is different. So we are saying communication, communication, communication. How can communication be done? There are two forms of communication. One we call it as synchronous communication, and the other we call it as asynchronous communication. In synchronous communication, I call somebody and I wait for the response. And only when I get the response, I would proceed further. Basically, it's a request response form of communication. And most of the time, the applications which are built for UI, they have to be doing synchronous communication. I click on a button. As soon as the button is clicked, some business logic has to execute on server, and at the same time some UI update has to happen in the browser. Then the communication definitely has to be synchronous. Whether it is browser based, whether it is mobile based, if a request goes to server, I'll show you why this gateway has come into the picture. The gateway or a ASP.NET Core web-based application, whatever. It can be either a gateway or an ASP.NET Core MVC application. This will further talk to the background services, and this also will be the request response model used. A UI layer most of the time would talk to the services using request response model, because it may not talk to both at the same time. It may talk to one and get the response and build the HTML output out of that and then give it to the browser. So unless it gets that output from here, it cannot build the HTML, it cannot decide what content has to be rendered. So obviously this call is supposed to be synchronous call. But definitely in synchronous call, there is a drawback if the same is implemented between microservices. Imagine a catalog service for some reason has to invoke the functionality of basket service direct. Or a basket service has to directly invoke the functionality of a catalog service. What will happen? Take this example. If a client application invokes the functionality of a basket, basket says whatever items are there in my basket, I'll convert that into an order. So basket calls the functionality of order. Because the order has been placed, appropriate quantity has to be decremented from the catalog. The order is now calling catalog functionality. Now catalog further calls some other functionality. Imagine this is not responding. Because this is not responding, this will not get the response when we'll wait. And because this is not getting the response and is waiting, this will also continue to wait. And because this is waiting, this will also continue to wait. Wait. The whole system is now waiting for each other, and the whole system would collapse. Deadlock would happen. Number of active threads which are available for execution of the request would become insufficient, and the whole system would crash. That's the drawback in asynchronous communication when one microservice is going to make a direct call to the other microservice. No, this is not the right way. So what is the right way? Use asynchronous communication. AMQP protocol is the asynchronous communication. Asynchronous message queue protocol, where one would simply put a message in the queue, and whenever the message is there in the queue, order will receive it. Basket will not wait for order. It will only deliver the message in the queue and forget it. order will put a message into the catalog, or maybe catalog will put a message for order when it is processed, or catalog will put the same message for the basket when it has completed and the response comes back. So I put a message into the queue and I remain peaceful and I wait for another message to come into another queue where the response would be available. That kind of communication is more common in asynchronous. Deadlocks will not happen, waiting will not happen. The threads will get released when they are not getting any message. The overall availability of the system is going to be very high when we have asynchronous communication implemented like this between microservices. Mind you, again I'm telling you, if you are building a UI layer or a gateway, from there it will be synchronous call, but between services it will be most of the time asynchronous call. And you know the reason now why it should be asynchronous. How is this implemented? That's where comes the role of the Azure Service Bus queues, the Azure Service Bus topic. But for you to understand that, in communication there are again two models. In asynchronous communication there are two models. For one message which is posted, there is one receiver, single receiver message based communication. Or it can be a multiple receiver message based communication. What is the difference between single receiver and multiple receiver? Say some message is something like, please create a new order. Do you want the same order message to be processed multiple times? We don't want the same order to be repeated. An order will contain the order ID, the order product details, and all this probably should be used by the order service for creating an order and persisting in the database. Same message should not be dealt twice. So this kind of thing is done with asynchronous communication where message queue will come into the picture. It's a queue model. And the pattern which is followed in this case is the command pattern. Basket microservice will post a message into a queue, and from that only one service would be able to take that message, which is order service and nobody else. Okay, good, fantastic. But what is this other pattern? Multiple receiver message based pattern. Subscribers will be there for the publisher. One message, multiple subscribers. A good example, if I take, the user details have been updated and these user details have been saved in multiple microservices in their respective databases. So how will user profile microservice, which updates the user data, inform all the other dependent microservices? Let it be basket microservice, let it be order management microservice. Say for example, a user has already created an order. So order is going to store not only the product details, order is also going to store the information pertaining to the user who has placed the order. Maybe the address of that particular user would be here. So as soon as the order is as soon as the user after placing the order updates the database with new address, obviously order service should immediately identify, and if the product is not yet delivered, it should pick up the new address and deliver. Same time, the basket microservice would also want to know something similarly about the product, about the user update information. Maybe a user has a type, and based on the type, he is only allowed to put so many items in a product. He is not allowed to put more than that many number of items in the product. Both of them would want to know type has changed or not, basket as well as order, and accordingly their logic has to be implemented. So basically there is one publisher and multiple subscribers. Same message has to be delivered to multiple microservices, and that's where we want to use topics. So here we use service bus queue and here we use service bus topic. One-to-one communication, but asynchronous. One-to-many communication and of course asynchronous is what is implemented. This is command pattern. This is event-based publisher subscriber communication. So in case of command, you always have to do this. Please do this basically. That's what is the communication. Command is all about future. This is going to happen. Command. For this topic to continue, you should come to the next session. That's a command. Post a command into the queue. Example, I want to send an email, place an order, delete a user. These can be commands. Clear the catalog. Command. Which is futuristic. Something which happened in the past is always an event. This has happened. Because this has happened, this is the event I want to subscribe. Product price has changed. Items should be updated in the cart. Order items have to be updated accordingly. Or maybe before the order is placed, the product price has been changed. The order should be cancelled. I don't want to continue executing the order with the old price because the price got updated. So both should know that the price has been updated of a given product in the catalog. That is going to be publisher subscriber model for communication. So in architecting solutions, this is the most important thing. Where do you want to use synchronous communication and how different microservices are going to do asynchronous communication, and this is where people go wrong. They say they are doing microservices architecture, but nowhere you are going to see asynchronous communication between services. Everywhere HTTP calls only will be made. One service will be called by another service by using HTTP client object. No, definitely you have already deviated from the microservices architecture because you have tightly coupled them. There are no more independent of each other. Dependency has come. This is the model we followed then. Microservices between themselves, if they have to communicate, ideally it is supposed to be asynchronous communication implemented using queues and topics. So with this, we understand that there are two types of communication. How are we going to deal with data in a microservices based solution? How are we going to deal with the gateway pattern? What exactly is a gateway pattern? What is the role of a gateway for different microservices when the microservices wants to provide their functionality to something like an Angular application or might be a mobile based application? In architecting a microservices application, what is a domain-driven design pattern? In domain-driven design pattern, what is a strategic, tactical, architectural design? All this, what is ubiquitous language? How the designs have to happen? What is CQRS, command query pattern, circuit breaker pattern? Create composite UIs with microservices. Of course, microservices have drawbacks also. There is not that everything is good about it, but how do we overcome those drawbacks with the help of orchestrating servers like Kubernetes? What are the benefits which Kubernetes provides to the overall health of the system is what we will now continue in part 2 of this particular session, which will be same time as on today. We'll continue exactly the same topic. And trust me, the part 2 is more complicated, more interesting, more complicated. Of course, right now, I repeat, we are only looking at all these topics in theory. Eventually, I'm going to practically demonstrate all these topics to you in course. Those who want to probably talk to me, I'm letting you come on Teams. Just raise your hand on Teams and I would take your questions one by one. The question answer session begins now. For 15 minutes overall, I'll be able to take up questions. So people who are on YouTube, if you have any specific question, you can definitely post it on the YouTube channel. If you're not able to switch to Teams, I'll take it from there. Or you can unmute yourself and directly ask me on Teams, Microsoft Teams. Please, before leaving, do let us know how was the overall session. Any kind of feedback you have for this session, good, bad, average, beyond your expectation, anything. Words which probably even motivate us to do more. Motivate me basically. Human being, right? Everybody needs motivation. Even I need. I'm just borrowing time. Yes, Pawan Kumar Pandey. Go ahead. Unmute and speak.
Hello, sir. Very good evening.
And in the meantime, 1 second, Pawan. In the meantime, I would definitely love to hear what are your takeaways from this particular session. What did you learn in this session? Please post that in the chat. What is that your learning is? You learned this today. You did not know this in the past, but you learned today. That is going to help me to probably customize my future session. I may concentrate on those topics a little more. So that would be a big time favor if you can put in the comments, put in the chat. What is that one extra thing which really kicked you today, which gave you a kick? Oh, that satisfaction it gave you. So please do mention that. I would love to see that in the chat. Pawan, please go ahead.
Yeah, thank you, sir. So very good evening. My question is, as you were explaining about the asynchronous call that one should implement in our microservice architecture, the only concern is, let us assume that I'm adding multiple product in my cart and that service is not yet completed and we did not get a response back from the order management microservice, and all of a sudden as a user I clicked on order placement. So what will happen and how it is going to take care of this asynchronous call
The
where
messages,
the one service has not...
Good point actually. Basically, yes, you're talking about how are we going to take care of the transactions which are distributed right, across multiple services. The messaging yes, systems which we are using, something like Azure Service Bus, they are considered to be reliable messaging system. So there will be a message posted into those queues, and unless these applications process those messages, they would not be deleted from here. They would stay there, and that's how reliable messaging system is going to help us in implementing transactions. I'm going to elaborate more on this topic with something called as eventual consistency. This is the explanation of that particular part which you're asking, which we are going to do in tomorrow's session. How do we deal with one service when changes the state? Compulsory the other should also change its state. It may not happen immediately, but eventually it will happen. So how do we bring that eventual consistency in place in a microservices based architecture? That input I'll give you in tomorrow's session.
Okay, sir. Thank you.
Yeah, hi sir, this is Shiva.
Krishna, I'll take Krishna first.
Okay, thank you, Sandesh. So my question is regarding mainly the asynchronous communication. So now say like we have multiple read-only services, okay? So do we still need to follow this async communication for read-only services as well?
Preferably yes, but just for the simple reason, think of it, right? You're calling me and I'm not listening to you. What will happen? You're only reading my data, right? Are you updating my data?
Right. No.
No. So you're only dependent on me to return data. And I am actually busy with something else. What will happen to you? You end up waiting permanently.
Right.
And maybe somebody else is waiting for you and the cascade effect will happen.
That's right.
So it's not just about updating the data. It's about two-way communication. We don't want that. So if I just deliver the whole subject and I damn care about what you are thinking, I am dumping my subject. Now, whenever you like, you take it. This video gets uploaded on YouTube and you now listen to it whenever you like. Don't you think that's more convenient? The only drawback is you will not be able to change your state according to my change of state. But that is okay.
Yeah,
you change exactly. Eventually. That is the advantage we take in microservices based architecture.
Right. But in terms of like the read-only services, right? So if you go with the async, like won't it be a performance issue? Because now say like I'm displaying some user profile information, right? So I'm trying to invoke that
That's
service
where
like
the
from some
Kafka
other.
comes into the picture. Various streaming services which are near real time, we will try to bring into the picture when we are so much concerned about performance.
Okay, okay. Got
Right?
it. Thank you.
Those things will have to bring into the picture. Saga, somebody said, those will come into the picture when we want near real time responses.
Okay, sir. Got it.
Ashok.
Okay. Thank you.
Hi, sir.
Go ahead.
Sir, this is Shiva. So my doubt is, so suppose users profile service is there, and this related basket and some orders service is there. While while updating user service, you mentioned this service buses. So we post this message into the service buses. So those detail will be updated through the service buses in respected services. Something happened in one of the service, so that identity value is changed. So in that case, how do you handle this database synchronization?
That's what I told you we will discuss tomorrow. Identity value will not change generally. That IDs will be in a way that they are idempotent. What is this idempotency and all that we will discuss in next session.
Okay. And is there any way to do we need to suppose if the one service in my one microservice I am in transaction I am using multiple services, sir. So in that
we'll
case,
discuss that
one of the service.
We'll discuss after my session tomorrow. You ask me those questions.
Yeah. Okay, sir.
Krishna.
Thank you, sir. Good session, sir. Thank you.
Krishna. Ashok.
Oh, sorry, sir. I actually already asked my question. I guess like I did not lower my hand.
Ashok, go ahead.
I just lowered.
Hi, sir. My question is coming to the difference between SOA and microservices. The service nature in SOA and in microservices is same. The technical characteristic of the service.
Correct.
Is it same? Okay. Just the way it is developed, or they are more independent. The more services for different purposes.
Very correct.
Okay. And all of the whole microservice is about the way it is a design approach. Basically, it's not a technology. It is a design approach.
Exactly. That's the crucial point. It's a design.
Okay.
Microservice can use any technology.
Got it.
It's a design which is important over here.
Thanks. I mean, this is one takeaway from me. For me, like I was thinking about it, some technology, WCF or something like that. It's basically it is a design approach. That's what I got overall.
Guys, this is very important message which you give me. What is your takeaway on this session? Somebody has clearly mentioned, understood the microservices in depth. Today I know about the difference between SOA and microservices. That's my takeaway. This is what I want, so that I know tomorrow if I am teaching this topic again, I can actually put my focus there. So please, please, please go back, rush your thoughts to last 1.5 hours. Which one has hit you hard? Please let me know that. I'm desperate to know that part from you people. That's the only return you can give me back for this particular session. The history of how this architecture evolved was very helpful and helped understanding this topic very clearly. Fantastic. Setting up the platform to explain the need for microservice was awesome. Okay, the starting point again. That's the point I would like to know, guys. I am from a QA and DevOps automation engineer. Would this course be useful to me? No. This course is exclusively for people who are .NET developers. Anybody not a .NET developer, don't burn your money on this course. Don't waste your time, don't waste your money on this course. This is completely for somebody who is expert on .NET, who is good at .NET, has some good amount of programming experience on .NET. Otherwise, you want to burn your money with me, I'm going to welcome. You'll end up doing charity to me, that's it. You'll not take the best out of this particular course if you do not know .NET. Can I have 10 minutes of your personal time? That's a lot of my personal time. I would suggest post it on WhatsApp. If anybody wants to talk to me personally, post me on WhatsApp. I'll check up what is the convenient time and I'll let you know. 9849001840, that's my number, and I'm in India. So any kind of guidance, I would suggest you post the message there, but don't do it today. I have back-to-back some more things to do today. We can connect tomorrow, maybe after 1 o'clock tomorrow.
One quick question.
We are facing a lot of performance issues with SOA. Now I learned if we could go for microservices, we will eliminate those issues. Fantastic. I don't have an idea about .NET Core. If you know .NET also, it is fine. Not necessary you should know .NET Core. .NET you should know. Good amount of C# programming you should have learned. Then definitely you can qualify for this particular course. I'll take the next question from Naresh. No, sorry. Sudhakar, the tester. Sudhakar, you're on mute.
Yes, sir. Yeah, sorry about that. Yes, sir. You talked about in the microservices comparison with SOA, you said the microservices that we create are specific to the application. So let's say I have a microservice called getFee or getUser. Would you create a separate instance of microservice for each application that's calling?
At least I'll create separate instance of the same code for each application. I may not want to run the same instance in multiple applications and mix them up. You might reuse the code, but the instance will be different. Got it?
Okay. Yeah, one follow-up question, sir. You said asynchronous, right? Command and event. Do they fit into a UI client that calls into these microservices?
We generally don't use UI for asynchronous. UI will be mostly making synchronous call to the service.
Okay. So no matter how many services you call, it's going to be a synchronous call.
Yep.
For a UI call.
Preferably. Okay. Preferably.
Okay.
Not essentially.
Yeah. One takeaway from this session for me is the synchronous versus asynchronity in microservices. I did not have that knowledge before. This was very helpful.
Nice. Thank you. Who is next? Naresh?
Actually, it's a nice session. I have two questions. Can you go to that gateway diagram?
Gateway will take up tomorrow, no? But if you still want to ask...
No, just yeah. Okay, sorry. So here, my small thing is here. Suppose if the UI is making any request to any microservice, so gateway has to take the decision to forward the specific microservice.
That's what we will discuss tomorrow. Actually, you're asking me a question about a topic which we'll take up in next session. We'll definitely discuss that.
Okay, and the second one is that same asynchronous call. Suppose a message packet reaches to one of the microservice, but that microservice again dependent on the another microservice. So in that cases, the second microservice is not exactly responding back that we discussed in this case. But as a developer, I have to debug certain things to why it is not breakdown.
That's the most complicated stuff. That's one of the drawbacks of microservices, what you are addressing.
Okay.
That's where you have to write unit test cases and then do the thorough testing of your service independently. Automation testing becomes very important for these kind of cases.
Okay.
So that you can eliminate most of your code and be very specific on where the error is. That's the drawback of microservices. You have hit the target?
Ah.
Gyan.
Yeah, is there any alternate alternate mechanism to, like, at least to figure out
unit testing? That's what I said, right? Unit testing, integration testing, these things developers have to build for microservices.
Okay, thank you.
Yeah, Gyan.
Sir, I have one question, sir. If you're talking about the microservice, as we have some tools like service mesh, like STO. So how will we use in microservice?
No, those are implementation details, man. Service mesh and all that is implementation details to ensure high availability infrastructure. That has nothing to do with the architecture. How the services come, that is different and this is different. I'm not so good at all that.
But
STO,
sir, DevOps,
service mesh, those are all implementation details, a platform basically for implementation of microservices.
Okay, thank you, sir. Okay.
Ashok, you're still up?
Basically, I am mostly into Windows application development, like using WPF, WCF, and all this. I think unless I move to web or cloud services, microservices might not be useful for me, right?
Ultimately, they are hosted as services in cloud now, or yeah, ultimately. And the warning bell should ring for you. It's the time, high time, you upgrade yourself to web-based application. You'll feel yourself outdated very fast.
Got it.
You are doing a suicide by not upgrading to web-based and cloud today. The moment that company doesn't need you, you'll become jobless. So be careful on this. Don't take that. Don't get into that situation. Upgrade yourself early, the better. Learn web-based application. Learn ASP.NET Core. Right? Pay some money to us and learn. From your earnings, invest. Otherwise, you will feel outdated. I have seen so many people coming to me and literally in stress and I would say depression that they did not upgrade themselves on the right time. And today they have 15 years experience, but all that is in legacy, which is useless. You will be worse than people who are very good in the modern technology for 2 years. So it's a warning which people should actually take it. You should be latest with the technology. And I'm telling you with authenticity of 25 solid years of experience in the industry and being latest always. In the session yesterday, we have discussed about what are monolithics, what is monolithic architecture, how web-based applications were mostly developed using monolithic architecture, and what are the benefits, and most important than everything was the drawbacks of the monolithic architecture. And because of these drawbacks, there was a need for introducing microservices architecture. So first I gave you the definition for what exactly is a microservice and how the architecture is different from the monolithic architecture, where a large application is broken into multiple small microservices. Discussed about all these things with example.
Excuse me, sir. Your screen is not shared on Teams.
Yeah, now I've shared it.
Yeah. Thanks.
Thank you. And then we have discussed what are the different characteristics of a microservices based application, and because of those characteristics, what is the benefit we get as a developer or as an architect of a microservices based solution. And then we have seen the design principles, certain live examples of how microservices were implemented. Very important, we have discussed the service-oriented architecture. What exactly is the difference between a microservices and SOA? A lot of people have confusion, and that's where we discussed the detailed difference between them. Went on to communication between microservices, when to use synchronous communication, when to use asynchronous communication. In asynchronous communication, when to use queue and when to use topic. Basically the difference between the command and events. And now we need to continue from where we stopped in the last session. Handling data in microservices. As already said earlier, in monolithic, we are going to have one single block, that means one single process where all the code is going to execute, and all that code of different modules will connect to the same database. Maybe for each module we'll have a different set of tables over here, but all of them will be part of one single database instance. Unlike that, in microservices, every microservice is supposed to have a independent database of its own. Yeah, there are some cases when we implement something like CQRS pattern, we might have special circumstances where between two microservices, we might end up using the same SQL database. But most of the time, every microservice is supposed to have its own database instance. Now, monolithic applications which have single relational database have very big advantage of ACID transactions. Atomicity, consistency, isolation, durability. We can quite easily implement involving multiple tables in the same database, all or none state. But when our data is split across multiple databases, how are we going to do this? That's the challenge which people have in microservices based architecture. We'll come to that point. But before that, what are the drawbacks? What are the drawbacks why we should not go for a single database for all the code which we write in our monolithic, or even for that matter, by separating microservices into different application, different process, why we should still not use a common database? Single point of failure. What happens if our server goes down, the database server goes down? The whole system will get impacted and everything is going to stop. You cannot scale your database so easily unless we manually take care of scaling the database. SQL Server, Oracle, when we want to do scaling, whether it is vertical scaling or horizontal scaling, that's not going to be automatic. We need to have some kind of manual intervention by the database administrators, where they have to increase the memory or the processor, or they have to add additional instances of the SQL Server and divide the load between them. And there is a limit. And this is going to be a really challenging job. When we use something like one database, we have got all code using the same database. So who has made changes to which table? There is no control. The project is crashing, or the data is getting inserted, or the data is getting updated in our database tables, but we don't know from where the queries are coming from, where the changes are being incorporated from, which line of code, which module of the application. It's going to be very difficult because there is no control on the ownership. But here we know that if this particular database is getting updated, it is the code in this particular microservice only which is updating it. Or if this is getting updated, only the code here needs to be checked upon. So we are narrowing our code in microservices based architecture, and it becomes clear distinction of who is the owner of which database. One of the biggest drawback in monolithic, if I have selected here SQL Server, everything is SQL Server, but not necessary. SQL Server would be the right option for some kind of data. I may probably want to have varying number of columns in my table. So in such case, no SQL is the right option. So I want for different type of scenarios, different types of data sources to come into the picture. That's again pretty much possible here, but here it's a one single database used everywhere, which is again a big concern. So yes, provider lock-in. So these are basically the drawbacks which we look at in monolithic one single database, and we pretty well overcome these problems in microservices based architecture. So the database autonomy in microservices says that the data owned by each microservice is private to that microservice and can be only accessed via that microservice API. This particular microservice will never perform any direct operations over here, or this will not perform any direct operations over here. Every microservice should have its own database, and that database can be only manipulated through that particular microservice. What is the benefit? The microservices become loosely coupled to each other. Any kind of changes made here is not going to impact here. Any kind of changes made here is not going to impact here. They become loosely coupled. And because they are loosely coupled, they can evolve independently. One microservice, I may probably already have version 5.0, but the other microservice, I may still have only version 2.0. We don't mind at all because they are independent, they are independently evolving. So the big advantage in microservice is every microservice can use its own kind of database, different kind. Can be NoSQL, can be MongoDB, right? These databases provide high performance and better scalability. So generally you should know when to use SQL Server and when to use NoSQL. When we want relational database, one table should be related to the other table, something like primary key, foreign key relationship we want, so that if the primary key is updated or the primary row is deleted, we want all the child rows to be deleted, that kind of cascade effect we want. Then in such case, SQL Server RDBMS, Oracle RDBMS, MySQL RDBMS, these are going to be the appropriate option. But otherwise, when we don't bother about the relationship between the tables, but our concern is more about distributed database system on different geographical regions. I have my data stored in India. At the same time, I have a copy of my data stored in USA. And any kind of changes made here, we want to be synchronized in that location. Any kind of changes we want made there, we want to synchronize in this location. That kind of requirement if you have for non-relational data, then NoSQL is a more better option. Yes, in SQL Server, the schema is fixed. Every table has fixed number of columns. In NoSQL, the schema is not fixed. Every entity can have multiple columns, and these columns can be different from another entity within the same table. So in NoSQL, maybe a computer, a laptop, a mic, a mouse, a monitor, all I can store it in one single table if required and perform some common operations on them. But that is not possible in case of SQL Server or Oracle, which are fixed number of columns for every table. These are not suited for hierarchical data storage. Let's say we want to have something like order management. We have an order table, but order table should be related to the customers, and order should have a nested list of items, and then each item further go deeper. So we want something like a hierarchy of data, something like a tree of objects is what we are looking at. That's much easier to manage in NoSQL when compared to managing that using relationship in SQL database. Yes, SQL database is very good when you want to write complex database queries. This is not so good for complex database queries. All your queries will be confined to only one particular table. You will not write queries which will involve join between multiple tables. Vertical scaling is okay. You can increase RAM and processor or decrease RAM and processor to save cost. But here you can achieve horizontal scaling. You can add more instances of NoSQL databases without impacting existing users. distribution of load can happen. Some concept of partitions are used with which we will be able to achieve horizontal scaling much easily in NoSQL. Of course, nowadays SQL Server, Oracle, they also support horizontal scalability through some concept of sharding. But that's not so easy as it is in case of NoSQL. ACID properties are quite easy to implement. That is where actually the big advantage SQL Server or Oracle has. But here we have got consistency, availability and partition tolerance benefits. Those benefits are sometimes more important than simple transaction. So the question big remains, which probably everybody gets in their mind: how are we going to perform transactions when we work with distributed databases and we are not supposed to write in single place code to update in both the places? This is something which is related to an action performed by one microservice is going to be treated as complete and successful when there is a corresponding reaction also done by another microservice. For this action, that should also react, and when both are complete, then only we want the action to be treated as completed. So how do we achieve this atomicity, ACID atomicity and resiliency when publishing the events to the event bus? So what actually is going to happen, you see here. Imagine my requirement is to update the product table. I already have all the products and this product table has to be updated. Maybe the price of the product has changed. So one microservice, which is your catalog microservice, is supposed to update the product table. When catalog microservice updates the product table, I at the same time also want to ensure that all the products by different users who have already added them to the shopping cart also should be updated here. It should not happen that one laptop which was like probably 50,000 rupees, and when the owner of the product updated that to maybe 60,000 rupees, people are still able to buy because they added into the cart earlier. The cart price also should be updated and should be reflecting it as 60,000 now, not as 50,000 rupees anymore. So how are we going to achieve this? If suppose imagine a situation where we updated this table and because of some reason after updating this table, before informing the basket, this crashed. So only the product in the product table got updated. The details of the product in the basket did not get updated. How do we update? How do we ensure that this is not going to happen? This is where we go for something called as eventual consistency, wherein what we will do is we will create one more table here in the same database where we have the product table. And we will first update the product table, and at the same time we will also insert one record in the event log table. Only when both the actions are completed, we will treat this transaction as completed. So one update statement is happening here and one insert statement is happening here, and the update and insert statement both should be part of one single transaction. That means if the record is updated here, definitely there is a new record available in this particular table. And here we will keep the state of the column, the value of the state column, we will keep it as ready to publish. When the new record is inserted, the default value we will give to the state would be ready to publish. And then we will also have some information about the event and event body, which is nothing but the type of table which got updated. That detail over here we will keep it. So transaction is completed, record is available here. In our microservice in catalog, we are going to write one more background process, or maybe at the same time when it is updated here and inserted here, the immediate next action probably in a different transaction would be to insert a message into the event bus, and when the message is posted into the event bus successfully, at that point of time update the event log table state column and mark that as event already published. That means we are changing the state from ready to publish to event already published. And when the state changes to event already published, we know event is already there in the event bus. Event bus is something like a reliable messaging system. Any message which is posted into the event bus definitely is going to be handled at the other end. So maybe not immediately, but sometime later, if the basket service recognizes that there is a message here, it will ensure that when it fetches the message, immediately the price of the products in its basket gets updated. So what is guaranteed here? If the product table is updated, because of the transaction, guarantee is there that both will be updated or none will be updated. And because of the other local transaction which is created, it is guaranteed that the message is posted into the queue, and at the same time the record here is updated from ready to publish to event already published. And because of the reliability of messaging service, we are very sure that yes, the basket service is definitely going to handle that message, and if it handles that message, it is going to update the details of the products which are already there in this shopping cart database. So this is how transactions have to be handled. Basically, it's not a transaction which will immediately reflect, but eventually it is going to ensure that at both the places the updates are happening. That's why we call this as eventually consistent transactions. In one single thread, they are not being performed. The thread of this microservice will be different, the thread of this microservice will be different, but the whole system implementation, when done like this, ensures that yes, overall the system is consistent. So like this, event bus is supposed to be used for posting messages which have to be handled on the other end. So this is how the data in microservices is supposed to take care of, and an alternative to the ACID transaction is. Now that we understand data, what could be the next thing? API gateway pattern. See, when we are having hundreds of microservices in one single application, what is the drawback? We have got hundreds of microservices in one single application, and if all these microservices we want to use in, imagine a Angular single page application, or maybe a React single page application, SPA, or maybe all these microservices we would like to use in a mobile based application being developed, which would run on an Android device or an iOS phone. What will happen? Or maybe some Windows based application, Windows service application, which would run on a client machine. The first major challenge would be all these hundreds of endpoints. The location of the microservice has to be exposed to the various types of client application. That means we are exposing a very wide surface of our system, and that can lead to security vulnerabilities. So in that case, we bring up a gateway pattern. Now what is this gateway pattern? All these microservices which are available here, we will ensure that are only going to have private endpoints. That means within the network here they are accessible, outside the network they are not directly accessible. And these private endpoints of these microservices we are going to register in a gateway. We call this as API gateway. There are different tools, different ways of implementing API gateway. You can use the cloud services as API gateway. You can use third-party services like Ocelot for implementation of the API gateway. Multiple options are available over here. Now, what is the advantage of this? Now, the big advantage of implementing a gateway is an intelligent service. Lot of rules can be implemented over here. We can do authentication and authorization at single point. Anybody who wants to access any of these microservices will have to only authenticate themselves with the API gateway. We don't have to implement security here because these are not at all directly accessible. So authentication, authorization with the gateway should be done. IP whitelisting. In gateway, we can configure and say that only these IPs or these ranges of IPs which probably are in a particular region or probably particular intranet will be able to access it. Not everybody would be able to access it. You can restrict the access through whitelisting IPs. You can check for the headers, query strings, claims, and if they come in one format, you can transform them in another format which is required by the microservices. Maybe the data comes in JSON format, convert to XML format, or if the data comes in XML, convert that to JSON. From one format, the data can be transformed to another format. Service discovery integration. Gateway will take care of. If at all the location of the microservice gets updated, I only need to change in the gateway. I don't have to change in any other place. But if this was directly exposed and if there were hundreds of applications, all the hundreds of applications will have to be updated with the new location of the service. Gateway can even do caching. For some of the microservices, it would generate the response and the response can be cached here. So that when a next call is made, rather than going to the microservice and getting the new output, from the cache itself, it can take the output and render it. So gateway can do response caching. Gateway can implement retry policies and circuit breaker patterns. What is this? We are going to see that very soon. But rate limiting and throttling also can be implemented at gateway. Maybe I would like to provide some limited functionality to people who want to do trial of my microservice. They should not be able to use it in production, but they should be able to use it in proof of concept. So I may want to introduce a rule like they should be able to call my microservice maybe 5 times in a minute. But when the 6th time in a minute, the same call is made, we want to report an error. So this kind of throttling implementations can be done at the gateway layer. Gateway can also behave like a load balancer. Gateway can be also used for logging, tracing, correlation errors, all those things because it becomes centralized. So gateway this way is basically acting as a reverse proxy. Reverse proxy. Why? Actually, this is the requirement. But instead of directly exposing this, we are exposing gateway as a reverse proxy to the client. The endpoint of the gateway is got the microservice will expose to the client, and the only way somebody can reach microservice would be through this gateway. Also, one big advantage which gateway can take is in gateway you can do request aggregation. That means one call will be made here and gateway can do multiple calls, get the data from multiple microservices, accumulate and create a single response and render that back to the client. So instead of client making multiple calls to the microservice, gateway is able to do request aggregation. That's also one beautiful advantage. In single request, multiple microservices output can be consolidated and returned to the client. So most of the time in real time, you will always see that a gateway is the way we interact with the microservices rather than going to the microservices directly. But a big but. What is the drawback of gateway? The biggest drawback of gateway is single point of failure. Imagine if this gateway has crashed, what will happen? Definitely, we will ensure high availability of the gateway. Rather, nowadays it is recommended that you use gateway implementations provided by your cloud service provider like Azure, AWS, GCP. And they ensure extremely high availability for these gateways. But what if for some minutes, some few seconds, the gateway is not available? The application is going to be not reachable and the overall system is going to fail. To overcome this problem, we can have gateway itself as more than one in number. So few related microservices, I will have one gateway, and few other microservices, I will have another gateway. That means we will bring related microservices together under one gateway and another set of microservices which are related to each other in a different gateway. We split the gateway so that even if one gateway is down, the complete system is now not down, but only partially it goes down. So that is one point which we have to consider while architecting a system. Gateways, if you are using, you are deviating from the characteristics requirement. Single point of failure should not be there. This is a big drawback which one has to consider when gateway comes into the picture. And then we have got the next part to be discussed in context of microservices, domain-driven design. Now, what is this domain-driven design? Honestly speaking, it's a very vast subject where the architects are responsible for identifying what exactly is the domain for which they are going to build the system. Maybe the medical domain, maybe basically the healthcare domain, or it can be a hospitality domain, or it can be a banking domain, or it can be a e-commerce domain. These are all different domains for which we want to build our application. So when we are trying to break a large application into multiple pieces, what are the different ways people are supposed to think of? That's where the domain-driven design comes into the picture. So DDD is an approach of building the software with the complete focus on a particular domain. You build your domain model. The whole approach is to properly build a domain model. What is a model? Basically identifying different entities and relating those different entities properly so that the data flow can happen between them easily. The connection, the relationships can be set up between them easily. That's what is a domain model. So in the context of building the application, domain-driven design talks about problems as domains having complex business logic. See, don't implement domain-driven design for simple implementations, only when there is a very complicated business logic implementation. Then only it is recommended to go for domain-driven design because its implementation is not that easy. For example, if you want to simply deal with something like a product catalog, where for a given category the products have to be fetched and displayed to the user, and you want to perform simple CRUD operations, create, retrieve, update, delete. No, don't use domain-driven design for that kind of purpose. But in an e-commerce solution, if you have a order management, right from the time the order is placed to the time where the order is either delivered or cancelled, everything has to be taken care of by the order management system. In that case, domain-driven design will come into picture because there will be a lot of business logic which will be implemented. For example, one customer should be allowed to place only order of 3 items for a particular category. Or one customer is not allowed to have more than this much volume of order. In a single order, so many items are only allowed. What should be the discount for each item? Who is going to provide delivery of those items? Different vendors probably would give. So like this complicated logic, when it is there, then it is worth for going domain-driven design. Otherwise, it is definitely not. It's not trivial. It's pretty complicated. So your domain is not complex. Don't use domain-driven design. First lesson, avoid. Just because many times we want to learn something we implement in our projects. That's a blunder. Don't do that. So here we have got 3 pillars of domain-driven design. Suppose imagine now you have thought of implementing domain-driven design. So if you have decided to implement domain-driven design, what is the approach? What is the way forward? You have to first look at the strategic design, then look at the tactical design, and then you have to look at the architectural design. In strategic design, we are going to break our large domain into multiple subdomains. So think of e-commerce project. We are going to break our large application into multiple subdomains. So we have got a subdomain called as product catalog in an e-commerce based application. We might have a subdomain called as orders, payments, shipping, inventory, authentication, authorization, customer management. These are all different subdomains for building a proper e-commerce system. So domain is e-commerce. After we identify the domain, we have to understand what are the core subdomains. What is the basic or core subdomain on which my business is dependent on, which probably is going to impact the success or failure, which is going to be resulting in success or failure of a business. So in an e-commerce system, how well is your catalog presented? How well you are giving details of the products? How well you can take care of the rating of the products and showcase them to the user? That is going to decide whether a person is going to buy a product or not. What are the different alternatives for buying? Those things will matter a lot in an e-commerce system. So this is going to become a core functionality, core subdomain in a major domain. Likewise, there will be some systems which are auxiliary or support domains. What are these? Only when the catalog is liked by the user, they would do some kind of orders. So order management is a support or auxiliary domain. Obviously, shipping is going to be a support or auxiliary domain. It does not mean these are less important, but it basically means that the success of this would need this and this. This and this are going to complement the success of this. That's why we call them as support, auxiliary. And then we have got the generic domains, generic subdomains. These domains are the ones which can be simply plugged into the system and plugged out. Most of the time these subdomains can be developed external. Maybe you can even outsource the development of these domains to some other team outside. Let them build the components and you directly integrate them into your solution. So those are generic, like payment gateway. Now payment gateway, whether it is for hospital management or for the hotel industry, the gateway is gateway. People are supposed to key in their credit card details, and then based on the credit card details which are provided, the payment is going to be success or the payment is going to be failure, and payment, if it is failed, there can be these reasons. That is going to be a generic system. In all the domains we can use the same set of APIs there. So is the case with authentication or authorization. So is the case with inventory management system for different products. So these are generic domains. So as an architect in an e-commerce based application, you identified this as the core domain, some as support domain, some as generic domains, and then for each of these subdomains you are going to create a bounded context. And based on this bounded context, you are going to implement a object model. Bounded context will lead to an object model where the entities will be there, value objects will be there, aggregates will be there, all these things will come into the picture. So bounded context is actually a problem space, and for that bounded context, creating an object model is the solution space. Identifying from the subdomain all the relevant entities, relating them with each other is the job of the object model. So subdomains will live in the space of problem, bounded context lives in the space of solution. Subdomains are logical separations, bounded context are technical solutions. That's very important. They are technical solutions. That means somewhere the routine day-to-day language of the business has to be converted to the technology language, where we talk about classes, properties, methods, fields, events. It has to be translated. And to do that translation, what comes into picture is called as a ubiquitous language. So after identifying a subdomain, the architect is supposed to create a bounded context, and a bounded context is on the basis of the ubiquitous language which is used for that particular solution. Now what is ubiquitous? Ubiquitous, the name has meaning, universal. It's a language which is supposed to be a set of terms agreed between the architects of the solutions and the domain experts of the business. The developers and the domain experts sit on the same table and they come to a conclusion that these is the jargon which is going to be used in implementation of the business in terms of automation. So that language is what is the ubiquitous language. Ubiquitous language should never be a set of terms and technical jargons imposed by development domain experts. No, domain experts cannot force the developers to use certain language. In contrary, ubiquitous language is developed in agreement of the whole team. The domain experts have to agree to the terms which are used by developers. So developers use technology terms. Domain experts use the terms which will help them to execute the business. There has to be a settlement between both of them. For example, a user cannot be called as user. In the context of sales, a user will become customer. So in customer service, it's a customer. In payment service, it is a payer. In order and registration, it's a buyer. Maybe in conference management, we'll call it as user. So this is in agreement. This is in agreement that in different contexts, the same entity is going to be called as differently. Different name is going to be provided. So this is one object model for one service. There is another object model for this service. Like that for every service, the bounded context. This is the bounded context within which these are the objects and these are the terms which are supposed to be used has to be crafted. And that's what is the main purpose of domain-driven design. Yes, when we talk about ubiquitous language, it must be expressed in a domain model. This is domain model. It unites people in the project. It unites the people of the project team because they settle on common terminology. It eliminates inaccuracies and contradictions with domain expert. It is not a business language imposed by the domain expert. It is a language which the business has in agreement accepted for the technology implementation of the business. It's not a language which is used in the industry. Obviously, this is the language which is going to evolve over a period of time. It is not defined entirely in a single meeting. You should be ready as a solution architect that when you're talking to the domain expert, there might be multiple sittings required to create an annexure of the different terms which you are going to bring in for a particular business. Concepts that are not part of ubiquitous language should be simply rejected. Don't simply try to jump every small piece you don't try to put into the system, which is not in the context, delete it. So this is the first requirement in a domain-driven design. We go for the strategic design, and strategic design is all about creating bounded context and ubiquitous language which are purely on the basis of subdomains of a large domain. Once that is done, we go for a tactical design, wherein in the tactical design we create entities. Properly we name entities and we define the fields in the entities. This is an object model. We have got an aggregate within which we have got entities, within which we have got attributes, and of course the functionality. You see now, we are not going to call the methods as create or insert, update, delete. No, the methods will be given like this: add order item, set address, calculate total, which represents the context of the business. This is because of the ubiquitous language, the naming has become like this. Unlike a developer who is always prone to give names like insert record, update record, delete record. No. Insert order, update order, delete order. No, it's not going to happen like that. Each functionality of the business is going to be identified and will be inserted like a method in the object which is created to represent that entity. Yes, there will be certain value objects which will have only data, which will not have any functionality. There will be certain aggregate roots, like this is an order is an aggregate root. The only through aggregate root order items can be added. This is child entity. So you have to identify in your system what are the aggregate roots, what are the value objects, what are the child entities which are dependent on the aggregate root. Like this you have to segregate everything. What are the different events, what are the services which we are going to use for probably performing repeated operations, like maybe a service is what I would use for updating the database. What are the factory objects through which other objects will be created? How will the events get propagated between objects to reflect the change in their state? All these things is going to take us closer to development. That's what we call it as a tactical design. And once we have the tactical design in place, we need to implement the architecture. There are multiple architecture. You can have an hexagon architecture. You can have a layered architecture. There are different architectures which can be used. The most popular in domain-driven design is the layered architecture, where we build application layer, domain model layer, and infrastructure layer as 3 different layers. And each of these layers is supposed to again have a set of operations which it is supposed to do. We don't want to do intermixing of this with this or this with this. Every layer has a set responsibility which has to be implemented. Like the application layer is going to depend on the domain model layer. This is the one which will be used by the users of microservice. The request will actually come here, but this will delegate the request to the domain model. All the functionality is implemented here. The business rules will be implemented here. Computation is going to be done here, and data will be returned back to the application layer. Application layer then would probably decide what data should be persisted, what should not be persisted. And if something has to be persisted, it is going to make use of the infrastructure layer, which in turn would talk to the SQL database, or maybe the MySQL database, or maybe NoSQL like Cosmos DB or MongoDB, something like that. This will take care of. So that's a proper segregation. What should be done by which layer, that should be drafted in the specification. So this whole system design is what comes under a domain-driven design. So now, not something which I would be able to express it, but in the main course, we practically implement all these aspects. We create a domain-driven design for an object, for an order microservice, and we ensure that all these things are created step by step, and we see how the communication happens between them in reality. Yes, in domain-driven design, we also use CQRS, Command and Query Responsibility Segregation Pattern. We try to segregate. See, it's a fact that reading is lot more number of times when compared to performing insert, update, delete. Anytime, most of the business you will see like that. I may insert a new product into the table one time, but thousands of times the same product details is going to be rendered to different users who are visiting that order, visiting the catalog page for that particular product. So why keep them all in one place? Separate them. So in a CQRS pattern, we will have all queries performed by one service where the read model is going to be implemented. And there will be another service which will take care of the commands. The command methods will be responsible for updating the state of the system. They are not going to return anything. Whereas queries will be responsible for returning the result, and they are never going to change the state of the system. So queries can be executed any number of times every time they give you same result. Yes, because the job is now separated between the domain service and the read model service. How are we going to bring consistency between them? As I explained to you earlier, the service bus is going to be the place where the consistency will be brought in. Any kind of changes made here a message will be posted into the queue or topic here, which will be retrieved and it will update its own database. Yes, as I showed you earlier, there is a good possibility that certain microservices use same database. So this can be like read model and this is command model. Both are using same database. This is a simple solution. But if you want that database also to be different, what is command model inserted should be made available to the read model. How is that going to be done? When the database is different, somewhere we have to probably write a background service which will read data from the command model database and update to read model database. Or we should use a asynchronous messaging between the two models for synchronizing themselves through a service bus implementation, which is done using something called as domain events. So this implementation is called as CQRS. You see here there is an event store. We will post data into the customers table, which will be stored as an event here. We'll post data into the orders, that will be stored as an event here. As soon as an event is added here, a new message will be posted, which will be viewed by the customer view service. Customer view service will be responsible for presenting the data about all the orders placed by one customer. So order service is different, customer service is different, and this is retrieving the events. So like this we have to take care of through some event store. Service bus can be an event store. Or if you want to really go advanced, you can use Apache Kafka, or in context of Azure, something like Event Hub. Stream-based communications can be done. This, as soon as places an order, immediately the order becomes available to this. Near real-time effect, if you want, high-speed event stores can be used for that purpose. So based on the kind of data you are going to deal with, based on the volume of data which you are going to deal with, you will have to use the appropriate cloud service, which is like Apache Kafka or something like Event Hub in Azure. Stream-based services they are. So when to use CQRS? When your system is very complicated and you want to separate the reading from the commands. Commands will be responsible for ensuring business logic implementation, input validation, business validations. We're segregating it. The tougher part, we are taking it out and implementing using domain-driven pattern. The easier part, maybe to read, I don't need domain-driven pattern. I would simply go for basic read operations. Domain-driven pattern gives us the advantage where we can have more, CQRS pattern gives us an advantage where the command service can be, let us say, having less number of instances when compared to the read service. Read service, I would run 10 instances in a cluster, whereas command service, I may run only 2 instances because the number of times the command is updating the database is far less when compared to read. And biggest advantage is developers can focus. The set of developers who are responsible for implementing business, they can completely focus on domain-driven pattern and the business rules and the business logic. And let there be a separate set of team who would only responsible for generating different type of queries for producing different type of reports. I want to see report of how many products have been purchased by a particular customer from this period to that period. Or I may want to, as a store manager, want to know how many products have been sold by different customers. So like that, different complicated queries one team can handle and the other team can take care of performing the complete order management or something like the complicated business aspect of a project through domain-driven pattern. So CQRS is a subset in domain-driven pattern. We use domain-driven pattern for implementing the domain microservice. We don't need to implement domain-driven pattern in read model microservice. That can be a normal microservice API. Yes, we are building large system. We cannot make a system which is failure free. We cannot build anytime an ideal system which is never going to crash. Always there would be a possibility of a system failure. But how do we handle it? That's what comes under the circuit breaker pattern. I don't want to invest a lot of time on this. But imagine now service A depends on B, B depends on C, and C depends on D. D has crashed. When D has crashed, service C is going to make repeated attempts to execute D. And when repeated attempts are made, the processor time is getting wasted. And when service C is not returning, service B will make repeated attempts. And likewise, service A will make repeated attempts. So why should we unnecessarily make repeated attempts when we know that service is not running? So basically we want both. We want repeated attempts to be made because the error might be temporary. Maybe a network failure has happened because my mobile was in my car with me and I'm moving from one location to another location. And maybe for few seconds I do not have mobile network connectivity, or internet connectivity is lost for few seconds as I was probably placing my order. So for that period of time only the service is down. But why should we break the whole system? So what generally we do is we implement retry model, wherein we keep retrying at a regular interval of time. But trying continuously again can be a problem. So to avoid trying continuously, unnecessarily, a circuit breaker pattern comes into the picture, wherein we have every service implemented in 3 states: closed, open and half open. So when a failure to the service happens, the circuit is going to be broken and it will no more forward the request. Immediate response will come to the caller saying that the circuit is open, the circuit is not closed. After some time, an attempt will be made, and if the success is not happening, still the event will be treated as closed. So state will be closed. Sorry, the state will be open only. The circuit will be open only. But when the success happens, it will be treated as half open. And in half open state, if a call is made with the success, it is like this. Imagine now service A wants to call service B. Suddenly service B crashed. Now service A will treat that as a closed circuit with service A. Service A to service B, the circuit is open now. Current cannot pass, right? When circuit is open, the current cannot pass. When circuit is closed, the current can pass. So in normal circumstances, when A and B both are working, the state of the circuit will be treated as closed. Calls are normal. But suddenly A finds that B is not responding. So what A does, it will open the circuit, and if it will keep it, let us say, for 5 seconds like that. In 5 seconds, if A is making an attempt to call the functionality of B, it is not going to go through. Immediately a response will go to A saying that circuit is open, your request will not pass through. After 5 seconds, the circuit will be kept in the half open state. And now A will again try to make a call to B. If it is success, circuit state will change to closed and normal communication between A and B will happen. But if it again fails, the circuit state will be back to open. So there is a circuit, which is again an object actually, whose state will define whether the request should pass through or should not pass through. Yes, little complicated. When we do practical implementation of this in our projects, we are going to see how circuit breaker pattern is implemented. But the whole idea of circuit breaker pattern is simple. We don't want to make unnecessary attempts to the other service when we know that the other service is not going to run for a while, and waste the processor time and the amount of threads, number of threads which are going to be consumed. So that's the big benefit of circuit breaker pattern. Yes, in microservices based application, even UI, user interface, is also treated actually as a service. So what we do is, if you have a large application, different components of the UI can be handled by different UI services. So for header, I'm going to build one microservice. For menu, I'll build one other microservice. For left nav, I'll build one other microservice. So the whole page, we will break it into different microservices, and each microservice will in turn, this is a UI composition microservice. This in turn will call other microservices in backend. These microservices will return result, which will be composed as a view model, and that view model in the form of JSON object can be returned to the client, wherein the Angular application probably can provide this UI. Or maybe here itself you use something like, if you are doing ASP.NET Core, you might use the components, ASP.NET Core component, in which a UI can be constructed from a view model, which is returned by the other microservices. So one of these implementation, basically we are again dividing the UI also. The idea is not only the business functionality, but even UI should be divided into different microservices, so that these UI components can be placed in the main page, the layout page, and the whole UI can be constructed with ease. Tomorrow if a footer has to change, why should I worry about these aspects? Only the footer can change because it is built independently. Only that particular footer content is going to be reflected. Others can, or probably for some time the footer may not be visible because that service has crashed. But that's okay. But rest of the things will be all available to the user. So what benefits we have seen with the functionality microservice, the same benefits we are going to get with the microservice which are going to produce UI as an output, or data which will be used for constructing the UI. So this is all about different types of terms which are related to microservice. But before that, what are the drawbacks? Yes, definitely by now you should have understood so many things, so many patterns which one has to have knowledge of. So it is not a job which probably somebody who is a fresher will be able to implement it. You should have decent amount of experience in programming world. You should have decent amount of understanding of how the applications are built. Then you can participate in developing microservices based application. But there is another angle to the whole thing. How are you going to architect microservices based application? Remember, there are two different things. A good solution architect can spoil or make a system. Imagine a building. If the building is constructed and if the pillars are not kept in the right place, how will the builder who is responsible for creating slabs and putting walls will be able to give a beautiful building and a beautiful interior? No. How a building is constructed by an architect using his civil engineering knowledge of what should be the pillar distance, what should be the strength of each pillar, how the rooms have to be divided in the building, how the kitchen should be separated from the living and the living should be separated from the bedrooms, how the floor has to be constructed. That's an architecture. Same is the architecture in building solutions for a given domain. Definitely architecture role is not going to do programming. The building architect is never going to hold a brick and put cement against it. He will never do that. But does it mean he doesn't know? Definitely he understands what is the strength of the brick, how much concrete should be used, what should be the amount of water, cement, brick should be used in all that he understands technology. So an architect is the one who understands technology but may not do his hands dirty, will provide solutions. Developers are the one who would actually follow the architect and build the system by writing code, which can be in C#, which can be in Java, which can be in Python, which can be in Go language. So many options are available today for building microservices based applications. .NET Core is one of the most suitable product for building microservices because of its small imaging in memory. The path which is required for execution of application in .NET Core in memory is far small when compared to .NET framework. .NET framework is considered to be heavy in memory. The whole architecture of how .NET Core is implemented is going to make it lightweight, and that becomes the most suitable. Likewise, if you are coming from Java community, you may probably use Spring Boot. Java with Spring Boot combination is very popular for building microservices based application. But yes, what are the drawbacks? Distributed system, and distributed system is always going to increase network traffic. Lot of hops. Communication is no more straightforward. Asynchronous communication always brings more complexity. You have to do failure checks. Retry code has to be implemented. And the worst problem is, what is the current location of the service? Where is the service currently located? If it has crashed on one of the nodes in the cluster, and if the service was moved to a new location, the new location should be made available to the consumer. How is that going to happen? So that is one of the big challenges which we are going to have here in implementing microservices based solution. Architecture adds complexity. We have already discussed. Latency is going to be one of the major factor in implementing, testing, exception handling. If a particular product is updated in the catalog, I want to be sure that the shopping cart has updated the price. We want to do integration testing thoroughly for this. And doing this is not as simple as writing one single line of code or few lines of code. You need more robust systems for implementing the testing of these kind of situations. Lot of automation has to be performed basically. Deployment is complex. Basically, you have so many dozens of microservices which are being developed independently, versioned independently, and they have to be deployed independently. The scaling factors have to be handled separately. Who is the owner of the product has to imagine how much job he has to take care of. We need a kind of dashboard where we can see the current status of all the microservices. Otherwise, it's going to become a chaos. Hundreds of independent microservices making up a system. Which one has failed? Which one are still up and running? Debugging and testing is difficult, yes. Especially when service bus comes into the picture. When messaging is asynchronous, very complicated to do testing. We have to compulsory use multiple repositories, source code repositories in GitHub or maybe Azure Repos or Bitbucket. Multiple repositories are going to exist, and with multiple repositories, multiple pull requests are going to be created. Huge amount of project management has to be done. Just imagine the amount. Every microservice is generating some output. We want to see all those logs at one place. I can't go to each and every microservice in the system and try to study the log. I want a solution where the logging should be at a centralized location. The worst problem is every microservice has got its own version. So what should be the version I should give for the system? Or complete application, which version it is? Every microservice is being developed independently and also version independently. And if the version changes, let's say from version A to version B, the format of the message is going to change in the service bus. How will the caller know that this is the new format and not the old format? The caller might have a cascading effect of failure. It is expecting the message in older format, but the data is in the new format. Architects have to keep this in mind. Distributed database transactions are hard, though I explained it so simply, but implementation of what I explained is not that easy. It's complicated. how to implement two-phase commits. You have to literally forget about the distributed transaction concept. You are not going to make use of those things anymore. Clustering is going to become an overhead. Orchestration tools are supposed to be used. Because of all these reasons only, today DevOps has become so important. DevOps can easily make things here. It can handle few of these things. Complete project management, deployment will be quite easy with DevOps. CI/CD pipelines will take care of it. We don't have to do it manually. So DevOps capabilities become very, very, very important in implementing microservices based application. But for other things like versioning of the application, we want to do replication of the components, ensuring automatic scaling happens as the load increases, distribution of the load between multiple instances of the microservice, trying to update the microservice without bringing it down completely, doing something called as rolling update, where if you have 10 instances running, I may upgrade two instances to new version, 8 would continue to serve. After these 2 are updated, 2 more. Like that rolling updates we would like to perform. We would like to ensure logging is at all one place. Monitoring and health checking should be consistent so that if the microservice has crashed, automatically it should be restarted. Crash is going to happen. You cannot say it will never crash. Some kind of error can occur and the microservice would crash. Maybe memory overflow. Resources required shortage. But we want to restart it automatically. So how is that going to happen? If the location of the microservice changes from one node to the other node, how the service is going to be discovered? How to ensure security, authentication and access to the microservice? All these things are handled by the orchestrations like Kubernetes. Yeah, there are definitely other orchestration solutions like Docker Swarm can be used. You can use Azure Service Fabric, which is big time failure. Even Microsoft today wants to support Kubernetes for almost all the orchestration requirements of managing microservices. Orchestration is all about doing this. Kubernetes will take care of all these things for us. The developer doesn't have to write code for auto scaling, load balancing, rolling updates, monitoring, service discovery. None of these plumbing jobs have to be done by the developer today. Developer can primarily focus on writing business logic, implementing rules of the business, providing the required functionality, invoking other services, posting messages, retrieving messages from the queues and topics. Developer can focus on those things. These plumbing jobs are all delegated, and that's how the system is little bit made simple for implementation. Kubernetes is the answer to so many questions which people have on implementing microservices. It simplifies application development because I told you focus is purely on the business. Rolling updates are implemented by Kubernetes. Service discovery is done by Kubernetes. Your persistent storage is taken care of by the Kubernetes. Load balancing, scaling, Kubernetes does. Healing, Kubernetes does. DevOps support for Kubernetes is extraordinary. Health monitoring is also taken care by the Kubernetes. If one node goes down, automatically the services which were running in that node will be shifted to another node. All this is done by Kubernetes. Yes, definitely we cannot think of a large enterprise application built with heavy traffic implementation in real time without using Kubernetes. We can't think of it. Rather, I would say because today we have got something like Kubernetes, the microservices architecture has become so popular for development. Of course, in Kubernetes, we deploy Docker containers for which Docker images have to be created, and every Docker image is going to have one microservice. which in Kubernetes is implemented like a pod. So it's an ecosystem which has to be built, guys. And that's how the microservices are going to take shape, and microservices application is going to take shape. So this brings us to the end of this particular session. Let me clarify everything about what I have spoken about in yesterday's and today's session, almost 2.5 3 hours. We are going to see these things practically. We are going to implement these things practically. I already have a course which is available online. We have microservices implementation using .NET Core. All these are already, what I have covered for you is this section. Obviously, we have got complete implementation, gateway, event-driven communication, CQRS pattern, domain-driven design, how to implement circuit breaker pattern, how to use retries and poly. Everything is already there in this particular course. But I am redoing this complete course once again now with the latest version of the technology, that is .NET Core 6.0. Said all this, I would definitely want you to take the opportunity to attend this class, which is going to be a paid session, same time from next week onwards. Saturday, Sunday, 5 to 8 p.m. 5 p.m. to 8 p.m. on Saturday, 5 p.m. to 8 p.m. on Sunday. Continuously, maybe at least for a month or more, we are going to have, at least 2 months, I believe, we are going to have this particular session conducted. That's all in today's session. I would definitely love to take questions, but I have some other commitment today. So whatever questions you have, please leave it for me in a WhatsApp group where you are the member, and I would try to take up from there and answer at later point of time. Thank you, and see you in next session in case you are enrolling for the course. Bye-bye and take care of.